So the mastoid process in the temporal bone is a bony ridge behind the auricle. So nandito, sa likod ng tenga, yan yung temporal bone, and yung mastoid process. It is the hardest bone in the body, and it protects the cochlea and vestibular system. Kasi dito yung area yan yung cochlea and vestibular system, di ba? Kaya nga, sa boxers, kapag sinusuntok sila dito sa side na to, dito sila, because naapektuhan yung ear, because the ear is not only involving hearing, it's also involving balance. Isipin nyo, I know if you have experienced yung matamaan kayo dito, ng open hand, ang sakit eh, and then the parang nahihilo ka eh, naapektuhan yung balance mo. The mastoid process also provides support to the external ear and posterior wall of the middle ear cavity. It contains air cavities which can be a reservoir for infection. So ito, air cavities yan. Pag nagkaroon ng infection yan, nagkaroon ng inflammation, tawag doon mastoiditis. Usually nangyayari yan galing sa, kasi later you will see, there's actually a connection between the nose and the ear. Kaya pag may sipon kayo, isa nagpipili kayo rin. You'll see that later. So, the tympanic membrane, or the eardrum, separates the outer and the middle ear. It's approximately 55 square millimeters in area and vibrates in response to sound waves and changes acoustic energy to mechanical energy. The umbo, this one, is the most distal point of attachment of the tympanic membrane to the malleus. So, hindi naman pwedeng mechanical yung aabot sa brain natin, bugbog yung utak natin. So, dapat electrical. The brain only accepts electrical impulses. So, there's also the semicircular canals. So, yung cochlea, sa hearing, yung semicircular canals, sa balance. No? And the vestibule connects the cochlea and semicircular canals. And it also contains two more balanced and equilibrium-related structures, the subtle and rudiment. Okay? So kung hearing lang, so part of the vocabulary, kung hearing lang ang pag-uusapan, sa cochlea yan. Balance, semicircular canals, and those two ones. Okay, so the cochlea has the appearance of a coiled snail shell, 2.5 turns and 3 fluid-filled chambers. The scala vestibuli, the scala tympani, the scala media. The scala media contains the organ of Corti, which I'll discuss later. So yan o. Again, pinakita sa video kanina, it's coiled. Pero it's easier to understand kung ipahaba mo siya. Kasi makikita mo yung different compartments niya. An organ of Corti is inside here. Scala media. So, di ba? Ito. Pag cross-section nun, imagine that as one long tube. A cross-section yan, ito yung scala vestibuli, scala media, scala tympani. The most important, of course, scala media because it contains the organ of Corti. So, what is it important? What is the organ of Corti? It is the specialized sensory epithelium that allows for transduction of sound vibration into neural signals. Okay? So, transduction. You're changing something from one form to another. You change the sound vibration into neural signals. So this is what does that inside the scala media. Inside the scala media. So there are also inner ear cells that transduce sound from vibrations to neural signals via the cheering action of the ear cells. Pinapakita rin sa video kung natin inner ear cells. Outer ear cells naman serve as a function of acoustic preamplifiers, which improves frequency selectivity by allowing the organ of Corti to become attuned to specific frequencies like those features. Okay. So for this one, mas importante lang na hindi na organ of Corti has this specialized sensory epithelium for sound transduction. So
this is an actual, if you look, nalagay nung sa high school kung meron eh. Kaya sa slides kasi, under a slide, yan, yung makikita mo na. This is the vestibular membrane, ito yung inner hair cells, outer hair cells, yan, maxillary membrane. So ito yung hair cells, inner hair cells, ito signal transduction pala. Okay, now we go to the balance system, the vestibular system. It consists of 3 semicircular canals, which I've shown earlier. It monitors the position of the head in space. It controls balance and shares fluid with the cochlea. These are the 3 semicircular canals. You have the posterior, the lateral, and the anterior. Okay? So balance, semicircular canals. Now, the inner ear, now we go now to the ear, more to the inner ear. The oval window, yung pinakita kanina, it vibrates when struck. Bali kasi, di ba dun sa middle ear, dun sa side ng eardrum, ang nakakabit yung values. Doon naman sa side ng inner ear, yung sa mga ossicles na nakabit doon, is yung stapes. So the stapes basically strikes the oval window. And then yung fluid sa loob nun, nasa-slosh back and forth. So there's also the round window I mentioned earlier. It serves as a pressure valve, and it bulges outward as fluid pressure rises in the inner ear. And of course, an important nerve in the ear is the vestibulocochlear nerve. It's the combination of 2 nerves, the cochlear nerve for hearing and the vestibular nerve for equilibrium or balance. Okay? So this is a very important nerve. Kaya nga, pag meron kang problema sa vestibulocochlear nerve, parehong hearing and balance ang apektado. Hindi pwedeng hearing ang apektado, balance mo okay. Palaging pag-apektado to, kasi it's a combination of 2 nerves. So, we go now to the process of hearing. So what happens? Okay? Funnel down through the ear canal and strike the eardrum, causing the vibration. I mentioned that earlier. Yung ating pina sa funnel, it captures sound, passing it through the canal, ear canal, or the external laryngeals, and then strike the eardrum, causing the eardrum to vibrate. Now, the vibrations are passed to the small bones of the middle ear, the ossicles, which form a system of interlinked mechanical nerves. And first, the vibration passes to the malleus, the incus, and then to the stapes. Okay. What happens next? So, nandun na tayo sa... So, as I mentioned again earlier, the stapes, it rocks in and out against the oval window, which is the entrance for the vibration into the inner ear. Now, the stapes agitate the perilymph of the bone villagranum. So, ina-agitate na yun. And at this point, the vibrations napasa na galing sa ossicles, the small bones, into the fluid. So, the vibrations now become fluid-borne. Andun siya yung vibration sa perilymph. The perilymph in turn transmits the vibration to the endolymph of the membranous labyrinth and then to the hair cells of the organ organ. You don't have to memorize per se. Just itibin nyo lang kung paano yung flow. Okay? Because hindi nga essay yung exam. Now what happens next? So the movement of these hair cells, which actually convert the vibrations into the nerve impulses. And the round window, so that the pressure is generated because of the sloshing back and forth of the fluid, the round window dissipates the pressure generated by the vibrations. Otherwise, ma-overload yung inner ear mo ng pressure, ng vibrations. So kaya yung round window mo is a pressure valve. Now, the nerve impulses travel over the cochlear nerve to the auditory cortex of the brain, which interprets the impulse as sound. Okay, so in the next lecture, we're going more into the neurophysiological basis for speech and language. So, dun mas ma-appreciate nyo ito kasi very, very technical. Okay? So, the end down. Yes. To be continued. Okay. So, any questions so far?
Ilang ulit mo na itinatanong sa'kin kung hanggang saan, hanggang kailan magtatagal ang aking pagmamahal, hanggang may himig pa kung